In this lesson, we are going to build the mental model behind WordPress performance. Before we talk about caching, hosting, plugins, databases, or page speed scores, we need to understand what actually happens when someone opens a WordPress page. This matters because a slow WordPress site can be slow for different reasons. Sometimes the server is slow to generate the page. Sometimes the database is doing expensive work. Sometimes the theme or plugins are adding too much processing. And sometimes WordPress returns the page quickly, but the browser struggles with images, CSS, JavaScript, fonts, or layout shifts. If we do not know which layer is slow, we usually start guessing. We install another optimization plugin, change random settings, or blame the hosting without evidence. That is not professional performance work. Let us start with the high-level flow. A visitor opens a URL in the browser. The browser sends a request to the server. The web server receives that request and hands it to PHP. PHP runs WordPress. WordPress loads core, plugins, the active theme, and data from the database. Then WordPress returns HTML. After that, the browser downloads assets like CSS, JavaScript, images, and fonts, and finally renders the page. This is the first important idea. WordPress performance includes both server-side generation and browser-side rendering. These are connected, but they are not the same problem. WordPress needs a runtime. It is not just a group of static files. The official WordPress requirements page lists the modern baseline: PHP, MySQL, or MariaDB HTTPS, and a web server that can run WordPress properly. For performance work, this tells us something important. Hosting is part of the application environment. PHP version, database version, HTTPS, server configuration, and resource limits all affect what WordPress can do. By default, WordPress is dynamic. That means the server usually generates the page for the request. It is not simply sending a finished HTML file from a folder. WordPress needs to load configuration, plugins, theme code, settings, content, and sometimes user-specific or request-specific data. Caching can change this behavior. A full page cache might serve a stored HTML response without running the full WordPress process for every visitor. But before we study caching, we need to understand the uncached model. Now let us make this visible. I am opening a local WordPress site and then opening the Browser Network tab. When I reload the page, the first important request is the document request. This is the HTML document the browser receives. That HTML is the result of server-side work. WordPress generated it using PHP, database content, plugins, and the theme. Under that, we can see other requests: CSS files, JavaScript files, images, and maybe fonts. Those are part of the front-end loading and rendering phase. This is why a page can feel slow for more than one reason. The HTML might arrive slowly, which points us toward backend generation, hosting, PHP, database, plugins, or theme logic. Or the HTML might arrive quickly, but the browser still takes time because the page is heavy or poorly structured on the front end. For backend visibility in WordPress, one of the most useful tools is Query Monitor. Query Monitor gives us a developer panel inside WordPress so we can inspect database queries, PHP errors, hooks, templates, scripts, styles, HTTP API calls, and other request information. Here on the local site, Query Monitor gives us a quick summary. You may see page generation time, memory usage, database queries, and template information. These numbers are only from my local demo environment. The point is to show that WordPress is doing measurable work for this request. Later in the course, we will use this kind of information more deeply. For now, just notice the categories. If the issue is database related, we need database evidence. If the issue is template related, we need template evidence. If the issue is front-end related, Query Monitor alone is not enough. We also need browser tools. The key point here is that the database is not separate from the page load. WordPress stores posts, pages, options, users, metadata, and settings in the database, and a page request may need multiple queries before HTML is returned. If there are too many queries, slow queries, or large auto-loaded options, the backend part of the page load can become slow. Query Monitor helps us see that work instead of guessing. Next, let us look at where plugins and custom code usually enter the request. WordPress uses hooks. The official documentation explains two types: actions and filters. Actions let code run at specific points during WordPress execution. Filters let code modify data during execution. This is one of the reasons WordPress is flexible. Plugins and themes can attach their own callbacks to these hooks. From a performance point of view, this flexibility has a cost. Every callback is code that may run. That code might be fast and harmless, or it might run database queries, load large options, enqueue assets, or process more data than necessary. Now let us look at the theme side. WordPress needs to decide which template should generate the page structure. The template documentation explains that WordPress determines the type of page being requested, then searches through the template hierarchy. For example, a home page, a single post, a page, a category archive, a search page, and a 404 page can use different templates. That means different pages on the same WordPress site can have different performance behavior. The theme is not just visual decoration. The theme controls the structure of the output. It can run loops, call template parts, load assets, display images, and trigger functions. A poorly built theme can create backend cost, front-end cost, or both. Now we can separate two major categories. Backend generation includes PHP execution, WordPress core, plugin and theme callbacks, database queries, and the server response. Front-end rendering includes images, CSS, JavaScript, fonts, layout shifts, and browser work. So, the first diagnostic question is this: is the page slow because WordPress is slow to generate the HTML, or because the browser is slow to render what WordPress returned? If the backend is slow, we might use Query Monitor, logs, Xdebug, WP-CLI, and hosting level checks. If the front-end is slow, we might use DevTools, Page Speed Insights, and Core Web Vitals. The tool depends on the layer. Google's Core Web Vitals focus on user experience metrics such as loading performance, responsiveness, and visual stability. These are front-end user experience measurements. They are very important, but they do not replace back-end diagnosis. The main takeaway from this lesson is simple. WordPress performance has layers. Do not start by guessing. First, locate the slow layer. Then choose the right tool. Then make a focused change and measure again. In the next lesson, we will move one step earlier than plugins and caching. We will talk about one of the biggest mistakes in WordPress projects: choosing a hosting plan before understanding what type of site we are building.